When a chemical reaction is performed, the amount of product that is produced in an experiment is known as actual yield. Actual yield is the amount of product obtained when the reaction takes place. Theoretical yield is the maximum amount of a product which is calculated using the balanced equation. Percent yield is comparison between actual yield and theoretical yield according to this relationship. So to get the percent yield, you divide the actual yield by its theoretical yield, then you multiply it by 100. Remember, so far we have learned how to calculate theoretical yield in different type of problems. The actual yield is actually produced in a chemical reaction and is a number that you obtain in an experiment, or it will be given in a problem. In the next problem, we learn what the actual yield is and how to calculate the theoretical yield and use the actual yield and theoretical yield to calculate the percent yield. Here we are given a reaction between lithium hydroxide and carbon dioxide to get the lithium bicarbonate. The amount of lithium hydroxide is 50 grams, which is used to do the reaction. When the 50 grams of lithium hydroxide was used in the experiment, 72.8 grams of lithium bicarbonate was produced. Since this number was produced in a chemical reaction, therefore this is our actual yield. We are asked to calculate the percent yield of this product. To calculate the percent yield, we need to calculate what the theoretical yield is. And like I said before, theoretical yield is a number for this substance that you get according to the calculations. So in this problem, we are going to use 50 grams of lithium hydroxide to calculate the theoretical yield of lithium bicarbonate. After we calculate the theoretical yield, then we can calculate the percent yield using the actual yield that is given in the problem. This is our plan to go from grams of lithium hydroxide, use this molar mass to get the moles of lithium hydroxide. After we get the moles of lithium hydroxide, we use the mole to mole factor between lithium hydroxide and lithium bicarbonate to get the moles of lithium bicarbonate. After we get the moles of lithium bicarbonate, we multiply that by the molar mass of lithium bicarbonate to get the grams of lithium bicarbonate. After we get the mass of lithium bicarbonate, this is known as our theoretical yield. When we get the theoretical yield, we use this relationship to divide the actual yield by theoretical yield, multiply by 100, then we calculate what is known as percent yield. In this problem, we need to find out the molar mass of lithium hydroxide, which is 24 grams of lithium hydroxide. We need to find the molar mass of lithium bicarbonate, which is 68 grams of lithium bicarbonate. We looked at the balanced chemical equation to get their mole ratio is 1:1 for both. After we get all the information that we need, then we start from the mass of the lithium hydroxide. We divide that by its molar mass to get the mole of lithium hydroxide. After we get the mole of lithium hydroxide, we use the mole to mole factor to get the mole of lithium bicarbonate. Then we multiply that number by 68, which is the molar mass of lithium bicarbonate, to get the mass of lithium bicarbonate that is produced in this reaction. Now we can calculate the percent yield. This number was given in the problem already, so this is our actual yield. This is the number that we calculated based on the balance equation. This is our theoretical yield. We divide them together and then we multiply by 100. Then we get what is known as percent yield. So far, we have learned how to calculate the mass of a product from the mass of one reactant. What happens when we have the mass of more than one reactant? If we are given the amount of more than one reactant, then we need to decide which one of those can be used to finalize the calculations. The one that is consumed completely is known as limiting reactant. So limiting reactant in a chemical reaction is the substance that is used up first and limits the amount of product that can form. The other reactant that is not used completely is known as excess reactant. When we are doing calculation, we need to finalize our calculation only using limiting reactant. To make this problem easy, what we need to do is to do the calculations like we have learned so far for each reactant. And then when we get the amount of the product based on each reactant, we can look at the number that is the smaller or the smallest, then use that number as the right answer, because that number was produced by the limiting reactant. In this problem, we are given the number of moles of carbon monoxide and number of moles of hydrogen, and we are asked to calculate the number of moles of CH3OH. Since we are given the number of moles of more than one reactant, it means one of them is the limiting reactant, the other one is excess reactant. We do not know which one is the limiting reactant, which one of them is the excess reactant, till we actually do the calculations. So to do the calculations, we will do this problem like any other problem we have done so far, but we will do it for each one individually. So it means for each reactant, we get the information that is needed to calculate the amount of CH3OH. According to the balance equation, for every 1 mole of CO, we get 1 mole of CH3OH. For every 2 moles of H2, we get 1 mole of CH3OH. We use these equalities to set up these conversion factors. Then we do the calculation for each reactant separately to get the moles of CH3OH for each reactant that we have in the equation. So the first one is to use carbon monoxide. We are given 3 moles of carbon monoxide in the problem. We multiply it by the mole ratio that we have in here. Then we get 3 moles of CH3OH according to carbon monoxide. Then we do the similar calculation for hydrogen. We start with the 5 moles of hydrogen since it's given in the problem. The mole ratio is 1 to 2. Then we get 2.50 mole of CH3OH. After we do our calculation, we find out that the number that is produced from hydrogen is smaller than the number that was produced from carbon monoxide. Therefore, hydrogen is our limiting reactant because it produced the smaller number of moles of CH3OH. From now on, we only can use this number to do any other calculations for these problems if it is required. To summarize what we should have learned in the problem we just did the calculation for, we have started with the 3 moles of carbon monoxide and 5 moles of hydrogen. Then 2.5 moles of carbon monoxide was used. All the hydrogen was used. Then we got 2.5 moles of CH3OH when the reaction was completed. After the reaction is done, we still have 0.5 mole of carbon monoxide left. Therefore, carbon monoxide is the excess reactant. We don't have any hydrogen left. Therefore, hydrogen is our limiting reactant. And this number was produced in the reaction, and this is the amount of the product that is formed. In the next few slides, you will learn how to use limiting reactant to find the mass of a product. In the previous problem, we learned how to use the moles of a reactant or the moles of a limiting reactant to calculate the moles of a product. Again, like any problems, before you do anything, you need to make sure your equation is balanced. After the equation is balanced, then you can start the problem, figure out what is given, what are you trying to calculate. And in this problem, again, since we are given the mass of 2 reactants, then we need to figure out which one of them is the limiting reactant and which one of them is the excess reactant, and finish the calculation according to what we figure out is the limiting reactant. We need to calculate the molar masses of each reactant that we have in the chemical reaction. We need to calculate or write the mole ratios of each reactant for the product, then come up with the conversion factors. We need to do the calculation for each reactant to get the amount of the product for each reactant that is used in the reaction. Now we can finalize our calculations using the number of moles of the product that was produced from our limiting reactant, and the limiting reactant in this problem was determined to be SiO2, and now we can calculate the amount of product, which is carbon monoxide, using the number of moles of SiO2 and get the mass of carbon monoxide.